Hello, hello. Welcome back. Taking a look at the headlines here for today, actually for this month. Of course, this is July, and the Apollo 11 moon landing happened July 20th of 1969. So we've been working through a lot of space program information and things of that nature, and I was curious about moon mission technology that may have filtered down to regular people. David Tracy wrote an interesting article about how high-level technology developed for the space program in the 1960s has influenced transportation, safety, and computers all the way up till today. Thermal protection, of course, is a big deal for NASA scientists who have the unenviable task of having to deal with temperatures as low as negative 455 degrees Fahrenheit in deep space and as high as 2,300 degrees Fahrenheit during atmospheric reentry. One material, Polybenzimidazole, or PBI, was a thermally stable, non-flammable textile fiber, and it was the subject of NASA-funded research in the early 1960s. The fibers formed from the polymer exhibited a number of highly desirable characteristics, such as inflammability, no melting point, and retention of both strength and flexibility after exposure to flame. The stiff fibers also maintain their integrity when exposed to high heat and were mildew, abrasion, and chemical resistant. Today, you'll find PBI fabric used in all sorts of applications, including firefighting and motorsports, where it is still used in race suits. Incidentally, one of the most common fabrics used in race suits today, and the one required for Formula One, is something called Nomex. That was a DuPont invention, and Nomex was among the 21 layers found in the spacesuits during the Apollo 11 mission. I have a small picture here, and it has a bunch of the different fabrics, the layers of the spacesuit, and although it's difficult to see, the Nomex layer is in here, created by DuPont for extra durability and heat resistance. Here's another one, the Dustbuster vacuum cleaner. How did this come about? Well, NASA needed a portable self-contained drill capable of extracting core samples as much as 10 feet below the surface. Black & Decker used a specially developed computer program to optimize the design of the drill's motor and ensure minimal power consumption. Refinement of the original technology led to the development of a cordless miniature vacuum cleaner called the Dustbuster. These are just a couple of examples that NASA sent me, but there are plenty more. Paul Sarazzuni, a curator emeritus at the National Air and Space Museum, told me in a phone interview that a number of innovations from Apollo likely trickled down into the auto industry. The main one he mentioned was the fact that Apollo was a very early example of digital control taking the place of mechanical control of a combustion engine, something that has since happened en masse in the automobile industry. Prior to Apollo, the rockets were controlled by mechanical devices. That Apollo guidance computer was really ahead of its time, especially with its integrated display and keyboard called a DSKY, or DSKY. Apollo's guidance computers set the table for computer control in automobiles. The Apollo guidance computers were early examples of what we would call today embedded computers, which now appear in everything from iPhones to automobiles, said MIT professor David Mondell, author of Digital Apollo, which explores how human pilots and automated systems work together to achieve the successful lunar landing. The MIT machines showed the world that computers, previously known as refrigerator-sized cabinets, could be made small and reliable enough for even the most demanding, life-critical applications. If you like this content, please send me an email, give it a thumbs up or like or comment on the video, and I will see you all the next time. Take care.